In today's video, I would like to introduce a very nice problem regarding arithmetic and number theory. Here is the following information. What is the smallest value n as a natural number such that we have x1 through xn as an integer number as well? Satisfy this following equation. We have x1 square plus x2 square all the way down to the xn square equals 2021 is raised to the power 2021. We have 2021 as a base and 2021 as an exponent as well. Okay. So now let's go through the question to explain the question a little bit because it seems a little confused here. So the meaning of the smallest value, which makes the expression is going to be written on this form. Okay. So as you're going up in n values, so we are going to extract from this equation the form which is going to write on the form of the squares, which is, I mean, sum of the squares is going to be a power of 2021 as we have here. Okay. So as soon as we find the n value, which makes this expression written on this form, as well as the right hand side of this equation, we are going to stop. Okay. I'm so excited to work with this one because it's very important and interesting problem. Let's take this number 2021. 2021 is going to be written on the form of 3 times is multiplied by 673 plus number 2 as a reminder. Okay. Let's reduce this one to my 3. If I'm going to reduce it to my 3, I get 0 here. I will be left with number 2 as a reminder. This one is a congruent to 2 my 3. Okay. But notice here we have an exponent here. Let's work with the exponent here. So I get 21 is raised to the 2021. This one will be reduced to the mat 3. So I will have 2 is raised to the 2021 mat 3. Okay. If you would like to work with this one, it will be a little challenged because we have number 2. If you had a number 1 or minus 1, it will be easier to solve. But since we have number 2, we are going to use a trick, or you can use the Euler formula in order to reduce this one. Since this one is easy to solve, we don't need the Euler formula. If Euler formula have something is bigger or more complicated, then we use that. But since this one is more simple to reduce, so let's just use a small trick here. Let's write this number 2 on the form of 3 minus number 1 is raised to the 2021. It's more simple. Number 3 will be 0 as a reminder because since we have a number 3 here. So I will be left with minus 1 is raised to the 2021. So since the exponent is odd, this one is going to transferred into minus number 1. Okay. Minus 1 mod 3. But in order to get rid of minus 1 here, I'm going to add number 3. So you can add them. You can add number 3, 6, 9, and all the multiple of 3. You will be fine. All are 0 as a reminder. This one you get 3 minus 1, which is 2. I get 2 mod 3. So I get this whole thing is a congruent to 2 mod 3. Now let's move on to the chart where we can make the comparison between the left and the right side of this equation. Okay. If you are going to use the chart and pick up a piece of values, I get in general chart k square. Why is k square? Because we are dealing with squares here. So you get the following values: 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Or it will be reduced to the mat 3. Let's take this one. I get 0 as a reminder. Number 1, number 2 square, which is 4. 4 will be number 1 more than 3. 3 is 0. 4 is 16, which is 1 more than 15, which is 1. 5, 25. 25 is 1 more than 24, which is 1. 6 square, which is 36, it will be 0 as a reminder. 7 is 48. 49 is 1 more than 48, which is 1, and so on and so forth. So this one belongs to this set k square, just 0. We found only 0, 1 as a reminder when we reduce this one to mat 3. Okay. Let's make this nice comparison between this fact that I found and with this reminder that I also found previously. Okay. Here is a little confused point here. So n must be super equal to 2 at least. Okay. Because we find number 2 as a reminder, because this one is telling us a strong information about the appropriate value of n, which we can make as this expression is going to written on this form. Okay, so if I'm going to straight to the main point, let's take number 3. Okay, if you take number 3 and then you try to collect the reminders of this one in order to make the remainder as an even remainder, which is the same remainder that I have here. Okay, so at the point 3 you get 0 or 1 as a remainder, then the maximum values of remainder that I can get at the point 3 is number 2, because 1 plus 1, which is 2, plus 0 is giving us always 2. So which means it's good. Let's take the value after this one to make just a comparison between this value and this value. For example, taking n equals 4 here is given as a remainder 3. 1 plus 1 plus, which is 3, which is impossible. We exceed this remainder. So n is strictly superior than 3. It's impossible. Let's talk about n is inferior, strictly inferior than number 3. If you pick up number 2, you get 1 plus 2 is okay. But remember, we get number 0 as well here in the remainders. We don't have only 1 here. If you have only 1 here, then we talk about 2 n equals 2. Okay, since we have this set is belongs to 0 and 1, we must take these 2 remainders, okay, as a sum, because if you are at the point 2, you get 1 plus 1. Okay, don't talk about 0 because we're starting the values from 1, okay, and up. So up to here. So we get the number 1 here plus number 1, which is 2, but we're missing number 0. Okay, this case is impossible because number 3 as a value is taking the priority. Okay, so if we take in n equals 1 is not enough because we get only 1 plus 0, which is 1. We don't get to number 2 yet. Okay, so the appropriate value of this one must be n equals 3. This is the right value. This is the minimum value, which make this expression is going to write on this form. So since I get n equals 3, let's express this one here. So I'm going to change the form now. So I have 2021, which equals 2 is multiplied by 1010 plus number 1. Okay, let's put this one on the form of the exponent. I get 2021 is raised to the 2 1010 plus number 1. Okay, I get here 1, I get here 2021 factor 2021 to the 10 to the 1010, all is raised to number 2. Okay, let's put this one on the form of squares. Okay, we know 2021 is equals 40 square plus 9 square plus 2 square is going to be multiplied by this one, 2021 to 1010, all is powered number 2. Okay, and let's replace this one with capital X. Okay, this x is going inside this square. I get 44x quaternary square plus 9x quaternary square plus 2x quaternary square equals to this exponent, equals 21 is raised to the power 21. Okay, so we get this expression, which is given, is written on the sum form which we have done. Okay, which means we have 3 sums here equals this power. Okay, so which is true. So I have a second method which is so nice to apply here, but I'm not going to do it now because I don't want to make the video too long. So maybe I can do it next time by creating another equation on this form, or cubed, or the power 4, whatever it is, then apply that method. You will be so interested to work on. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching and enjoy the rest of your day. Bye.